Hello! Okay, so this feels so weird. I'm doing this in my kitchen, okay? And my husband is behind the camera. Okay, so I want to talk to you about Newton's second law. I didn't make a video for Newton's first or third because they're really easy to understand, but Newton's second law is always the hardest one that gives most people the problem, okay? So, Newton's second law, okay? So, it says that acceleration, oh my goodness, varies directly with the amount of force. We'll just say force, okay? Okay, acceleration varies directly with the amount of force. So this law works in two ways. There's an inverse relationship and then there's a direct relationship, okay? So the other way is that acceleration varies indirectly, so this is the opposite one, with mass. It says mass of the body, that's just getting fancy, don't worry, with mass, okay? Because the big equation that we're working with Newton's second law is force equals mass times acceleration. Okay, that's the big equation. Okay, so how I try and remember this is by, and if we were in class, I would use a giant meter stick. Okay, that's my meter stick. Okay, I don't like that. It's a little bit better. Okay, okay, there's my meter stick. And on this side, I would put my M for mass. Here would be my force, and here would be my acceleration. Okay, so you see in your booklet how you have two little diagrams with rulers on them? Draw this out, okay, with me, okay? I can see you right now, you're getting a pen. Okay, so if force is constant, okay, so whatever one we're gonna say is constant, I'm gonna circle, okay? So if force is constant, okay, if I decrease the amount of mass an object has, I'm gonna increase its acceleration. Okay, like a teeter-totter. Okay. But, and same thing goes vice versa. If we increase the mass, we're going to decrease the acceleration, as long as we're pushing with the same amount of force the whole time. And I'm sure right now you're like, what? Okay, but it'll become clear. Don't worry. Okay. Second one. So this is inversely. Okay. So. Okay. Next one, okay, so again, mass, force, acceleration, okay? On this side, I'm either going to keep mass or acceleration constant, okay? So if I keep mass the same, okay, if I increase the force on an object, I'm also going to increase its acceleration, okay? And vice versa. If I decrease the amount of force, I'm going to decrease the acceleration of an object. Okay? Let's take a look at these in a couple examples that you'll be like, ah, okay, now this is making a little bit more sense. Okay, so let me erase this. Oh, not a good idea. I took pens from school, but I didn't take any of the things to erase these whiteboards with. Okay. So let's look at a couple of examples. Because remember I said it's all the conceptual understanding of it. I'm not worried about numbers. Okay, here you go. Let's draw out a graph. Okay, so let's say a car is driving down a highway. After braking, it stopped. What is happening to the force? Okay, so I'm going to also draw my ruler underneath here. Okay, force, oh sorry, mass, force, acceleration, okay? Okay, so what's staying the same? Mass. As I'm driving, the mass of my car isn't going to change, right? So that means I'm going to have a direct relationship because these two are either both going to go up or both going to go down, okay? So it says a car is driving on a highway. After braking, it stops. What is happening to the force? Okay, so we don't know what's happening to the force. That means that force is on the y-axis, and that means acceleration is on the x-axis. Okay. So if I have a high acceleration, I'm going to have a high force, right? So I'm driving quickly, okay? And as I slow down, okay, the force also slows down at the same time, okay? My husband's giving me a weary look behind me. Okay, let's try another one. Where did I get this? Please draw these out yourself. You can just do it on the page underneath there. Okay, here's a different one. Okay, bungee jumping. Okay, you jump off a bridge. What's tied around your ankles? Okay, right, it's kind of like an elastic rope, not a chain rope, right? That would make things really dangerous, okay? So same thing. So let's draw myself a little graph here. I'm going to draw my ruler, force, mass, acceleration. Why do I keep on doing that the wrong way? There you go. Okay, a bungee jumper jumps off a bridge. As he is falling, his acceleration is increasing. What is happening to the force he creates as he falls through the air? Okay, so what is happening to the force? Okay, we don't know what force is, so that's going to be on our y-axis. Okay, is his mass changing? Does your mass change as you're flying through the air? No, okay. Mass is staying the same. Okay, so as we're falling, what's happening to our acceleration? Faster and faster, okay? Which means our force is also going to be going up, okay? So the graph is also going to look like this, okay? Here's acceleration, small amount of force, large acceleration, large amount of force, okay? Doesn't matter what the numbers are. Notice how these are both direct relationships. The graphs look exactly the same, okay? Let's try a different one. Clean this up very easily here. Okay, this is M, F. Okay. When you're pushing a cart of groceries down the aisle of Sobeys, not today, but you know, earlier, if you keep adding groceries, what is happening to your acceleration if you push with the same force? So imagine you have your cart, you're walking down the aisle, you're not changing how much force you're pushing on the cart, and as people start adding groceries into your cart, what's happening? Okay, so the force is staying the same. Okay, so notice how these two variables on either side are on opposites. So this is our inverse relationship. Okay, so we're trying to see what happens to acceleration. Okay, and it's the mass that we are going to be changing. Okay, so when we have a low mass, we have a high acceleration. We can go really fast. But as we start to add groceries and our mass of our cart gets higher and higher, look, our acceleration is going to decrease. Okay, so this is the inverse. This is the direct. Direct, low, low, high, high. Inverse, high and low, low and high. Okay? Two other ones. Okay? I always like to draw the ruler because it just helps me give me a reference. If I was in class, I'd have like post-it notes on a ruler, and I would just tip the pen or the ruler, put it on pens too. Okay? So this is A, F, M. Okay. You're pushing a cart of groceries. Okay. Be honest, it's just pop and chips and hot dogs down the aisle at Superstore. If your mom spots your cart and starts removing objects quickly, what is happening to your acceleration if you keep pushing with the same force? Same force, okay? So what's happening here? We don't know, so acceleration is on the y-axis, okay? What's happening to our mass? Is it increasing or decreasing? Okay, that's right, it's decreasing because your mom's grabbing all your treats out, okay? So our mass starts high and it goes low, right? When we have low mass, we're able to push that cart really fast, okay? increases, our acceleration goes down. Okay? So this is an inverse. Oh, you're like, Miss Labiuk, you didn't put the variable here. Here is mass. Okay? And the last one, you're trying to push a stalled car out of a ditch. Maybe you're super nice and spotted your friends in the ditch in the winter. Okay, here we go. A, F, M. Okay, you're trying to push a stalled car out of the ditch. If your unhelpful friends jump into the car as you are pushing, what happens to the force needed? Okay, so is the mass of the car going to change? No. Okay, so our mass stays the same. Okay. Oh, lies. It says if your unhelpful friends jump into the car. Ah, so our mass is increasing, right? Our acceleration is going to stay the same, okay, because it's not moving. And how much force are we going to need? Okay, so force we don't know. Mass we know is going to be increasing. So if we start off with our mass here and our friends jump into the car, our mass will be increasing, and therefore the amount of force we need would also have to be really high. Okay? So I hope that gives you a better understanding into Newton's second law, and I will give you a couple more questions like this to try out yourself.